Connecting to cloud server. Yeah, it should be ready. Okay, so hi everybody. And first of all, thanks for having me. This is my first card, let's say. So allow me to go through this card. It's a part of my demo that I have done myself, so it will help me. My name is Fanis Prodromou. I'm Angular instructor and tech director in CodeHub. It's a private institute, and we do trainings in various departments. I'm responsible for the Angular one, and I work there for about 3 years, something like this. I'm a front-end lead in the company Architects. In the meantime, I'm authoring the book, Mastering Angular Reactive Forms. So following the discussion that we had previously about the reactive forms, I hope not to have that many backwards incompatibility when they change something, because my book will be out of date soon. So I hope not to have something like this. I expect to have it ready at January and have it in the market at March, something like this. I'm a co-organizer of Angular Athens Meetup. And on the bottom right corner, you can see my contact details. Prodromou F on Twitter, blog.profanis.me, my blog. I have some cool articles there, or at least they're cool for me. But you can check them out. And if you want to connect with me in LinkedIn, you can find me in Prodromou F. So let's start. Today's talk is about how to create a Trello-like application with Angular and GraphQL. And mainly, we will focus on GraphQL, mainly focusing on Apollo framework, which is a very cool framework. And I use this one for both backend and front end. So the application that I'm going to present you, the Trello-like application that I'm going to present you, is actually a monorepo, which is based on a min stack, Mongo, Express, Angular, and Node. And of course, we have GraphQL with Apollo for the communication between back and forth. The first bullet point, the first item in the agenda is what is GraphQL. And you don't have to have any experience about GraphQL for this talk, at least. I will start with very, very basics. Let's say from zero, and we will go on some degree so that you can have a common understanding of what the GraphQL is and how to start using it in your application. And last but not least, we will talk about the Trello app. And of course, I will approach it. It's not because the Trello app, it's a huge one. It has many, many things. I will try to approach it. So let's start by what is GraphQL? And REST has become the dominant API style for communication between backend and front end. And that's why I will present GraphQL basics from a REST perspective, since we have, I guess that all will have a very good understanding of what REST is. So in REST, we have the verbs like we saw. We have get, post, put, delete, and patch. Let's think for a while how those verbs affect the data source. For example, with get, the only thing that we're doing is to query data. We're getting data from the data source, right? Whereas with post, put, delete, and patch, we are mutating the data source. We are changing somehow the data source. Now, if we try to group them by action, we can say that get is in one group, and this is query, and the other verbs, post, put, delete, and patch, are in the other group, which is the mutations. So we have two different groups, query and mutations. Now, on the other side, on GraphQL, the only thing that we have is query and mutation. So from now on, when we will discuss about query, you can imagine that with query, we're going to get some data. Whereas if we discuss about mutation, you know that we're going to update something. We are going to mutate the data source. Either this is going to be post, boot, delete, or patch-like. So this is going to be the mutation. In order to have a common understanding for this talk, let's discuss about the payload and what the payload is and what kind of payload are we going to exchange between the backend and the front end. So imagine that we have the front end and sends a GET request to the server, the backend, and the backend responds back with this small JSON object. This is just a project with 1, 2, 3 properties, and we have also the tasks, which is another property which has an array of some objects. I missed to update you about this talk that I'm going to spend some time about how to have GraphQL in backend. I promise you, I'm not going to make it long for the backend, but it's very, very important to present this in order to understand the mechanics of GraphQL. So speaking of backend, imagine now that we have to create this project in the backend using TypeScript. How can we do this? We have to construct two different interfaces. The first one is the project, and the other one is the task. In project, we have the ID of type number, the name of type string, and tasks of type task array. And here we can see also the other one, which is the task with ID number and name of type string. Okay, so imagine that this is an ideal world, at least for front-end developers, that will have to code in TypeScript. But what about now in GraphQL? So GraphQL has a domain-specific language, and it's a strict type language service. This is actually what GraphQL is. So we can construct our queries. And for this, we have to have some types. So similar to what we saw previously in this slide, now we have the type of project and type task. So we no longer have interfaces, we no longer have classes, but we have types, which is reserved to GraphQL world. And what we see is how we convert a type, how we convert, let's say, a model in GraphQL. It's not a TypeScript, but it's look like a TypeScript. So on the left side of column, what we have is the property name, and on the right side, we have the type. So ID of type ID, name of type string, and we have here also the exclamation mark, which denotes that this field is required. And also we have the tasks, which is a task array. And on the other side, we see how we form the task. Similar idea, ID of type ID and name of type string. And again, this one with exclamation mark is a required field. Now, I will try to be like back and forth between REST and GraphQL, and to have a smooth understanding of what we have in REST and what we have in GraphQL. Now, think the following, that we have the client, and the client wants to have a communication with the backend and play around, let's say, with projects. So the backend is like, okay, I know what I have to do. I have to create an endpoint, and this is going to be projects, like we see here. So now, from now on, the client, in order to get to play around with the backend, either for get, post, put, delete, or patch, all of these verbs, all of the communication is going to be under this endpoint, projects. Okay, now imagine the following. Imagine that the client wants to get a task, a specific task of a specific project. The backend is like, I have to create for this one another endpoint. So it's going to create projects /ID/tasks. And whenever now the client has to play around with this endpoint for all the verbs, has to use the new endpoint that has been created by backend. And now imagine the following. So currently we have two different endpoints. And now imagine that the client this time wants to play around with tasks, regardless of any project. How can we do this? We have, of course, to communicate with the API developers and ask them, can you create something new for me? And of course, they have to create another endpoint for this one. And let's say this is going to be /tasks. And for get, post, put, delete, and patch, all of these verbs, we have to use the new endpoint. So with REST, whenever we want to have something new in front end, we have, of course, to have a communication with API developers, with the backend developers. Now, let's see how we have this in GraphQL. Again, if the client wants to play around with projects, the backend is like, what I have to do for you is to create one endpoint, and this is what GraphQL has. For all the communication between backend and frontend has only one endpoint, and this is GraphQL. No more than this. So if the client wants to play around with projects, it's going to send the queries to GraphQL endpoint and the mutations to GraphQL endpoint. Imagine now that we want to have a specific task of a specific project. Sorry, wrong button. I have to go all the way back. Here we are. So for this one, if we want to create, to get a specific task of a specific project, again, we have only one endpoint, and this is GraphQL, both for queries and both for mutations. And now, if we want, again, to play around, the clients, if we want to play around only with tasks, regardless of any project, the backend is like, dude, we have only one endpoint, and this is GraphQL. And for all the communication, again, query and mutation under the same endpoint. This is one of the cool things that GraphQL has. And the reason is that we do not have to have back and forth communication between the backend developers or the API developers. We have the power in our hands. But now we have a question. The first question is from client side, and is like, how can I get the data from the server? Because we know that if I have REST, and if I want to get a list of projects, I have to send a request to /projects. If I want to get tasks, I will send a request to /tasks, another endpoint. But what about in GraphQL? And the other question on the server side is, what kind of schema am I going to return and when? Of course, we are front-end developers. We don't care about this. So we are not going to spend that much time on the server side, but we will spend a little, some time to explain some things. If we sum up, we can say that the client is responsible for what, and the client is responsible for what, and the backend is responsible for how. Like a sum up, let's say. Let's start with the client. So the client has the power on its hands to construct all the queries. What we see in this slide is a legit GraphQL query, and we also have a timeline on the bottom here. So if you are an SQL guy, so this query is sort of like this. So what this SQL query does is select project ID, project name, tasks name from projects, and here we have an inner join. Something similar we have in this query. We are requesting the ID and the name from projects, and we are requesting the name, which are joined with the projects, and we're requesting only the property name from tasks. Imagine now the following, since we have the timeline, that the product manager at some point of time wants to have some more requirements on the list. And it's like, you know, guys, I want also to display the description on the projects. The only thing that we have to do is just change the query. On our end, on front end, on client side, we don't have to communicate with the backend. And if, for example, later on we have more queries to have the description on the tasks, again, we have just to update this query. And this is very important. What about if we don't want at all to have the tasks? Again, we have just to update the query. This is very important, and we will see later on why this is very important. And if you are curious how all of these happen, all the communication, let's have a look on this one of how the queries look like on the developer tools. So all the queries are, as we said previously, and are under the same endpoint /GraphQL. They are following the same verb. Everything is a post. For a front-end developer that has a vast experience with REST and respecting the principles of REST, having all the communication with post, it's a little bit unusual, but this is how it goes. Because actually what we are doing, we are posting a query to the backend. And this is how the query looks like. All the queries that we send to the backend return back as a JSON. So we don't have to worry how to construct our templates because everything is going to be then like a JSON. Now, let's jump a bit on the server side, and there's a reason to do so. So this is the backend code, but it's very, very, very important to understand the mechanics. So the backend split the code in different, let's say, resolvers, and each resolver is responsible to handle a top-level query. On the right side, we have a query with two top-level queries. The first one is projects, and the other one is tasks. Think now the following. What about if we do not query the tasks from front end, from client? So the task resolver won't execute. This is the power. And this means better performance on the backend and less data in the wire. This functionality, we do not have it with REST. With REST, all we have is most probably all the projects with all the tasks. But if we want to omit somehow the tasks, we just have to remove them from the query. And this kind of resolver won't execute ever. And this is very cool. Another cool thing that we have with GraphQL, and especially with Apollo, is that we have a documentation and an embedded documentation, which at the same time is a playground. In REST, what we have is the OpenAPI specification, the Swagger tool, for example, which is very cool. But what we have also is, let me show you. We have an embedded playground and at the same time documentation. So what we see here is under localhost in port 3001 is runs by server. Under /GraphQL, what we see here is a panel which splits in two sides. The left one, we can create our queries. And on the right side, what we can see is the results of the query. And this actually looks like a video, but it's not a video. It's a button to execute the query. On the right side, we can see this green thingy, a green button, which says schema. And if we expand this, we can see all the queries or all the mutations that exist on the backend. And what we can see here is that we have project with some variables, projects, task with some variables, and tasks as well. And we have some mutations, new project, update project's order, remove project, and new task. And this is our documentation, but this is not only this. If we click to see more details, we can see that projects return something of type project. Type project, what does that mean? These are all the fields of type project. We have ID, we have name, we have tasks, we have order. And if I click further, we can see more details. For example, here we can see that tasks return something of type task. What does that mean? This thingy. These are all the details. So having the queries, what we can do is start creating our queries immediately on the playground. For example, let's say that I want to have a query, and I want to query, we have also autocomplete. I want to query projects. And from project, I'm going to get the ID and I'm going to get the name. If I click the execute, here we can see that we have in the backend, in the database, in the Mongo database, we can see that we have two different projects. The first one is with name to do, and the other one is with name work in progress. We can add more. We can add, for example, the order. And if we click the execute, we can see also the order here, 0 and 1. And now you might be wondering, and why do we call this GraphQL? Because we can create our own graph. For example, we can say something like, I want to get specific tasks of this one. And we can see that the project with name to do has 1, 2, 3, 4, 5 different tasks. Let me pause a bit here and open once more the documentation. What we can see here in the tasks is that, have a look here, we can query directly the project from the tasks. So this means that this is how we can create our graph, and we can go crazy with this. I can be like, you know what, I'm going to have the project for this task, and I'm going to have only the name. If I execute the query, what we can see is that under the project with name to do, we have a task, and this task has a project, belongs to a project with name to do. So this is how we can create our own graph. And of course, we can go even further crazy with this and have an infinite thingy. Of course, this has some limitations, and the backend developers should have also a limitation on the backend in order not to have a very huge query. So this is how we have the documentation, which is very, very cool. Another cool stuff with GraphQL is the following. So imagine that we have a client, and the client wants to play around with products and customers. If we are under REST, in order to get the products list and the customers list, what we have to do is we need two different round trips. Whereas with GraphQL, what we have is everything can combine in one query. So let me show you. I will delete everything from here. And let's say that I want to have, as we saw previously, a list of projects, and I want to have only the name. If I execute the query, we can see this one. What about now, if I want to have only the tasks, no more than this? We can be like, okay, I want to have the tasks, and specifically, I want to have the name property. And these are the tasks. And now, how can we combine both of them in one query, in one round trip? Simply, we can just have to have here project name. And if you see the results, we're going to have different property for projects, and we have name to do and work in progress. And if I collapse this, we can see all the tasks. So this is one round trip. Now let's see a little bit about the Apollo framework and what we have from Apollo framework. Actually, everything that we have in this application is based on the Apollo, but I think it's nice to list them down. So with Apollo, we saw that we have queries. With queries, we have some more options. And the first one is polling, which means that we can execute periodically a query every 500 milliseconds, every, I don't know, 2 seconds, 2000 milliseconds, and so on. Or if you do not like to have a polling, you can refetch a query on a particular user action. And this is the refetching option. We have the mutations, like we saw previously, and we will see more details about the mutations and how these work later on during this talk. We have also subscriptions. So with subscriptions, we wire up a GraphQL with a pub subsystem like Redis to implement subscriptions in GraphQL. In a nutshell, what does that mean is that when the backend has something ready, just publish something to the client, and since the client is subscribed, that's why we have the pub sub. We also have optimistic UI in which we can simulate the results of a mutation and update the UI even before receiving a response from the server. We have a pagination. There are many ways to implement the pagination, but as far as I know, I haven't tried this before, but I think there is a specific method about this, and it's called fetch more. It has a very nice state management. And you might be wondering now, whenever we hear state management, rings a bell, and we're like, okay, we have NGRX, we have NGXS, we have Akita, we have many other tools. With Apollo, we have an embedded state management, does excellent job, and we will see also how to use it. And with state management, we have also Apollo framework's CAS, the embedded CAS, and we'll see how to start working with this CAS. And of course, it has a nice error handling. Now, this is, let's say, the theory. Let's pause a bit about the theory, and let's see some action, and let's see how to have the Trello app. Before we start anything, what I have in mind, and this is how I structure my job, let's say, is that the first thing that I have to do is construct the documentation, instruct the documentation. What do I have to do? And the second step is create the query. The third thing is that we have to consume this query in the service, and later on just to inject the service in the component. And these 4 steps we're going to follow to see some more details. So this is how the Trello application looks like. Of course, it's not like a Trello, but I try to approach it. The funny thing is that my Greek friends can understand. If we write Trello in Greek letters, it's spelled like Trello. and Trello means crazy. So this is our crazy board. The first thing that we are going to do is to get some projects. And the vertical are the projects, and the items that we have inside are the tasks. So let's see how to get the projects. As we said, the first step is the documentation. And we have to see the queries, because this is what we want to do. We want just to get data. So we don't care about mutations, but we care about queries. And this is what we care about, projects. If we click, we can see more details, like we saw previously. And the step 2 is to construct the query. What are you going to get? I'm going to get projects, and specifically ID, name, and order. And I also want to have the ID and the name of the joint tasks. Okay, nice. The third step is to create the service. This is no more than just a very simple singleton service. And to convert this service to a more meaningful to Apollo client, we will extend the query like this with one generic type, and this is the response that this query will return. So this one is going to return projects, and inside projects, we're going to have a project type. And this is how the service, the end service, looks like. We're pasting just the query that we constructed previously inside here, and we'll have our first query in a service, in Angular service. Cool. The fourth step is to start using it. How to do this? Of course, we have to inject in constructor the service. So we have our injection, and then on the onInit, for example, on init hook, we can be like, this project DQL. This is very interesting. We have .watch, value changes, get the data. This is no more than like RxJS operators, but watch is very cool. And the reason is that with watch, what we're doing is that we are registering an observer to the cache. Like I said previously, Apollo has a state management, and at the same time has, of course, its own cache. So with Watcher, we have an observer on this cache, and we'll see how this works. And the fourth step, of course, is to start using in the component. I'm not going to spend a lot of time in the component, at least on the slides, but what I want to present you is the flow that GraphQL and the Apollo has. With component, we just said it previously, a watcher. The watcher is an observer to the Apollo client, and then the Apollo client, the next step is to send the query to GraphQL API server. From GraphQL API server, we have the data, we have the results actually, and having the results automatically, Apollo normalizes all the data and updates the cache. Here we have those two arrows, and these arrows means that with Apollo client, we can use the same query that we sent to the server, but this time to have a query directly to the cache. Yeah, we have two options: query the server, query the cache, and we'll see how to do this. So let's have a look. So this is how the application looks like. What we have is, currently we have two different projects, to do and work in progress. We can delete the items, the projects. We can drag and drop. We can click to see some more details. Here we can see that this is task 1 in list to do, and this is tasks 2 in list work in progress. If we expand this, we can see on the network, I will just send a reload. We can see on the GraphQL that what we send is under GraphQL, we send a post. And what did we post? This is the query. And these are the responses, the data. We can add more. So we can add a new project, and we will see later on how this is going to work. I'm not going to show you now. We can create more tasks. For example, we can have the task 5, task 6, and so on and so forth. So this is how the application looks like. And I think that the reorder works. No, it doesn't. And this is what we'll have to fix. So in this talk, we will try to fix the reorder, and we will also try to fix this one. So if I have now done, at least we don't have it in the UI, but we should have it in the UI. If I reload, we'll have it here. Sorry. So we'll try to fix this as well. So let's continue. And the next one is how to add a project. And this is more interesting. And the flow is actually the same. The difference is that this time we'll have to handle the cache manually. In order to do this, we need 3 steps. The first one is get the slice of the cache. The second one is mutate the data object. And the third one is write new data in the cache. And of course, the first step is the documentation. This time, we're not interested in queries, but we have to check the mutations, and especially new project. If we click new project, we can see here that we have accept some variables, and these variables is the input. And if we click more, we can see that this input is actually no more than a name property, no more than this. And you might be wondering why this like this, because the backend developer decides to have the new project mutation to have it like this. And here we can see also the details of project like we saw previously. The second step is to construct the query, or this time to construct the mutation. So this is how it looks like, new project, and we're providing here the input, and we said that I want to provide only the name, and this name is going to be to do. So this one, what I have now in the red border, is the request to the server, and all of these are the response from the server. What we're saying is that as soon as this is done, I'm going to get back ID and name. Okay, nice. So let's start with the service. No more than a simple service this time, but again, let's add more semantics, more Apollo client, more GraphQL semantics. And this time we don't extend with query, but we extend with mutation. And this accepts a generic of 2 types. The first one is the response, and the second one is the request variables. And we have to paste here our mutation. If it's the first time that you see the mutation and GraphQL in general, it might be weird a little bit to see this code, but this is just the semantics of GraphQL. And believe me, after if you write 1, 2, 3, or 4 mutations, it will be like your cup of tea, let's say. It's very easy. And the other step is the component. And this is the interesting part. Think now the following, that we have a method, the add project that accepts 1 argument, name of type string. Okay, so new project GQL, not query, but mutate. And we're providing the input, which is just the name. Now, let's see how we're going to update manually the cache. The mutate accepts, the first one is the input variables, and the other one are the options. So this one. So in the options, what we can have is start using the update method. And this actually is the way to handle manually the cache. The first step is to get the slice of the cache. Of course, in Apollo, they do not name it like slice, but if you have an experience with state management, this is how we call it. And I have an experience with state management, and I call it like a slash. So that's why I present it like this. And how to do this? So we have the store, read query. With read query, if you remember previously, we have like 2 different arrows, and we discussed about that we can set a query directly to the cache. We are doing this with the read query method, and we have to provide the query. So this is my query of how to get the data. The second step is to update the state. Of course, more mutations should happen here. And the third step is to write the query, to update the cache. So here we have write query, and here we have read query. So let's have a look how this look like. Like we saw previously, we said that what we want to do is to create here something, a new project and automatically to see the project appeared in the list. So let's see the code. Let me collapse everything. So in the source, I will go directly on project list service. Let's keep this here. And also I will open the components, the containers, and this one. So what I really like to do in order not to have that many injections in my component, I prefer to have all the queries in one service. That's why here I have the project list service. And with project list service, I have some methods. So this is the get projects, this one. And this is the add project. So let's try to compare those two, add project and get projects. What we have here in get projects is project GQL dot watch, and we're just, as we said previously, we have an observer in the cache. Now, let's work on the add project. I will remove these comments, just add a comma here. And now with this one, in the update method, what we're doing is that we're getting the slice of the cache, we're updating the state, and we update the cache. Let's see how this should look like. So if I have done and add list, it's here. So let me reload and see also the network. Again, done, add list. So we have only one query, no more than this. And this is the new project. As soon as this is done, we updated manually the UI. And it's interesting to understand the mechanics here. So here what we are doing is like, I want to have the query, to query the data is going to be with this one, this project GQL document. If you see here, we use the exact same query. So this is how Apollo slices down the cache, let's say. Imagine that here we could have like, instead of watch, to have like a fetch. What does that mean? This means that we will get all the data, but we won't have a watcher, we won't have an observer in the cache. And if I have here another list, let's say, another project, I will name it like project one, at least we have it on the server, but we do not have an observer. So sometimes it's nice to have also here the watch. Let's see something else. So what about now if I try to reorder? It should work, but it doesn't. So if I reload, we have it here, but I want to have this immediately on the UI. We have two options. The first one is to use the update, and the other one is just to have a refetch query. So what we are saying here is that as soon as this is done, I want to refetch a query. Which query? This one. Where do we use this query? Here. So Apollo knows that as soon as I'm done, I will get the data, I will update the cache, and since this guy, this method has an observer to the cache, will automatically update it. So now if we have the reorder, we can see the details. Of course, we have a glitch here, but this is about how we refetch the data. And of course, we can remove, and with remove, I just have here, I use the update method. So if I click here, done, no more here, no more here. So let's go back to the slides. And the last thing, let's close with some more configuration. The last thing that I would like to present to you is how to have the configuration. So I have a module for this, GraphQL module. And what we're doing in the providers, what we have is we're providing the Apollo options. And for this one, we have a factory, no more than this. And what Apollo has is the so-called links. Many frameworks, many libraries decide to have their own terminology, but sometimes they mean the same thing. So I like to have in mind the links like being the middlewares or like work like interceptors. So the first one is that the on error link. What does that do? Error handling. So here we have two different errors to handle. The first one is the GraphQL errors, and the next one is the network errors. So imagine that here, what you can do is also to have alert messages, like toast messages, or even here on the GraphQL errors. So you can have a generic error handling for all the application using the on error link. And the next one is the HTTP link, which just connects the front end with the backend. So having this configuration, you have the option, of course, to have the communication back and forth. And 3 more bullets in order to understand the problems that GraphQL solve. The first one is the no need to have multiple round trips, and why this is solved with GraphQL, because we can have one query and combine many queries in one batch and have only one round trip. The second problem, and this was the first thing that I decided to start working with GraphQL back then, it was way more data transfer than required with REST. So I used to work in a hospitality product, and the products and the results that I had from the backend was a very, very huge payload. And I was like, you know what, we have to minimize this. And of course, we had to have many communications back and forth with the backend developers in order to minimize and chop out some things, some properties. With GraphQL, we don't have this thing because we are responsible, the front end is responsible to do the queries. And the third one is the API versioning and the maintenance. So again, this is a good one because you don't have to create another version. You just have to create another method. And other method means that you have another resolver. And so this reduces, of course, the maintainability of the backend. And that was all. I hope you enjoyed it, and thank you very much.
Thank you very much, Fanis. That it was quite nice. I like that he started from kind of for beginners like me in GraphQL. So that's really nice to see how we kind of all pieces together. Quite interesting. So we've got some questions, and we've got some people here with their hands up. Stephen, I think you were the first one, so we'll go to Stephen first. If you want to ask the question, please. Stephen, are you there? You can open your mic and talk. Well, we'll go to the next one.
Maybe we can just have the question in the chat.
Yeah.
If Stephen has a problem with the mic.
Yeah, okay. I can't see anything in the chat from him.
Okay. I'm not sure how can I check.
Maria, I think you had your hand up as well. Okay, I'll ask a question. Okay, go on.
I wanted to ask, is it possible to have a look at this repository?
To have a look on
this on the code of Fanis.
Yeah, definitely. At the end of this, and very good question, Maria. Thanks for this. At the end of this presentation, I will share with you the slides along with the code. And my idea is to extend this application to look more like Trello. So if you want to play around with GraphQL, feel free to contribute on this one. It will be just a playground for you. So feel free.
Thank you so much. I love the idea because I was thinking of developing something similar. But I have a question because I'm also new to GraphQL. If I want to use an existing API, obviously I cannot use it as GraphQL, right? So I'm thinking to be concrete, I want to do something where I'm using the calendar API of Google.
Okay, I know what you mean. So there are many architectures of how to do this. So what you can do with GraphQL is like, imagine the following, that here you have your client and the client communicates with something. Let's say that this is the question mark. And what about if you have to consume many different REST endpoints? The question mark could be like, let's say, a GraphQL server, and this GraphQL server to gather all the properties, all the requests from all the other services and send back to the client. So what you are asking, yes, it is possible. You can do this. And how you can do this, let me go back a bit. So if you remember, we saw something like the resolvers of the backend. Let me find the slide. Where is it? Yeah, here. So what you can do is in a resolver, just execute the results with the API, get the results so that you can just return to your clients. Something like this. I haven't done this before, but this is what I have in mind.
So you suggest that we make our own GraphQL server in between, let's say.
Yeah. If you're going to play around with the GraphQL, yeah.
Right. Thank you.
Welcome.
Cool. I've got a question as well. So from what I saw there with that cache, it looks like it's doing some sort of optimistic update, isn't it?
Yeah.
So the question is, if for some reason it fails on the server, does it automatically delete the entry in the cache?
If fail, for example, just to have a use case, let's imagine that they're going to do something, they remove project and fails. If I have fallback, you mean?
Yeah, is the deleted project then show back on screen and then basically, and then of course with an error saying, there was an error.
Actually,
we can't delete it.
This is the optimistic UI, and there are, of course, we can have this. So with optimistic UI, so let's imagine that the execution of a mutation, X mutation, takes, I don't know, 10 seconds. At the same time, between this time, we can remove something from the screen, and if fail, just revert it back. So yeah, this is possible. Very good question.
Okay, nice. There was somebody else that had their hands up before. Can't remember who he was. Any other questions from anybody else? Leon, go on, Leon.
Hello. Yes,
Hello.
I don't really have any questions. I played with GraphQL a couple of years ago, and it's one of those things where the industry hasn't really moved in that direction. So I've never really had a chance to use it yet. So this is more of a refresh for me. But it was a great explanation, and yeah, thank you.
I'm glad you liked it.
Thank you.
So
I think there was another question from Mr. O about what kind of queries will the client library generate, and will they be optimized?
What kind of queries the client generates?
Yeah, Mr. O, if you want to ask that question again, or
So actually, the queries that the client, are you referring to these queries? So let me zoom this in. What kind of
I think
the client generates is how we post them. Is this the question?
No, I think he's gone. Can't see him anymore on the participants. So I'm not sure. Any other questions from anybody else? Can you actually manipulate any caching? Like if we want to bust the cache or something like that, I don't know what sort of options do we have there for caching?
Yeah, actually, there is in Apollo Client version 2, as far as I remember, there is also a way to handle the cache besides of the mutation. So there is a way to handle directly the cache. And the cache, like I said previously, and I missed to present this one, so there is an extension of Apollo.
Oh, that's nice.
What I said previously is that it normalizes the data. So this is how the normalization look like. So we have a project and an ID, and here we have a task and an ID. And yeah, we have plenty of ways to affect the cache. And speaking of this tool, you can also have a playground here, let's say. So let's say that we're going to have projects. It's a good one.
That's nice. That's nice. Yeah, so it basically does what the normalizer library we would normally use for
Exactly.
NGRX. Yeah.
Exactly, like the normalizer, as you said. Very, very, very good one.
Yeah. That's cool. So yeah, this kind of removes, I would say, the need for managing the data in the global state. I guess you can still use NGRX for any state management, but for maybe UI, yeah, if there's
So,
any UI, global UI state that might be needed, I guess.
yeah, this
Doesn't
is
fully replaces NGRX or
no.
any other.
I don't think it's a good idea to replace it fully. It's a very
Yeah.
good, like you said, Alex. So in the past, I didn't combine both of them, but what I had in mind was a clean separation of I have the, let's say, a sync state and sync state. So GraphQL is responsible for anything that came from backend. But if I want to have session state, form state, component state, so on and so forth, this one is NGRX or whatever.
Yeah.
That's
Yeah.
a very good point.
Yeah, makes sense. How do you handle file uploads?
Another question, please.
File uploads.
Yeah, actually, that was very hard, very, very hard. It took me at about 2 days. And in order to do this, I don't have to have the code here, but I had to update a little bit and create a manually link. So the link was responsible to understand that this is a multi-part and convert it to a multi-part with blobs and so on and so forth. So it was hard to do it, but there are ways to do it.
Yeah, cool. Yeah, I mean, it's I say a common problem to solve. So there should be, I guess, some helpers as well there somewhere, like libraries maybe. Yeah. So apart from Apollo GraphQL, is there any other library? I suppose there is, but yeah, I'm not sure. And how it compares with other libraries, what, the benefits and...
I think there is Prism as well. I haven't used it before Prism, but I think that it's very good on the market. And I saw some presentations. I don't remember the guy that presented this one, and created a monorepo so that we can have also the same type from server to client.
Okay.
He had 3 different layers, let's say, model, server, and client. And speaking of these, so think the following. So here in the project list service, for example, here on the mutation, we had to create this by manually. But we have also the option with Apollo to create all the queries, all the mutations automatically. So just have a communication with the backend, and there is from the Apollo, it has the option to create services for you. And this is a cool one. But for this presentation, I decided to have it manually. But just to go back on your question, I think Prism is the other one, but I haven't tried it.
Okay. Yeah. So they don't have the monopoly.
Sorry?
They don't have the monopoly on GraphQL.
They do not have it.
That's good. Competition is always good.
Exactly.
Any other questions? Looks like not. Thanks again, Fanis. Really good presentation. I hope everybody enjoyed it. Oh, wait, we got a question.
Thanks for having me, and thanks for the setup. I really enjoyed it. Thank you very much.
Okay, we got one more question. So, Dan, what was the question? Sorry.
Can you only use GraphQL for a node server, I think?
Sorry, come again?
So the question was, can you use GraphQL for anything else but Node?
Yeah, you can use it. A friend of mine now, he used it with Python, and the stack is Python, and the backend is PostgreSQL, and they have a middle layer, let's say, with Hasura. So this is another setup. But yeah, there are ways. There are other backends as well to start using GraphQL.
And then George is also asking, so GraphQL service is a replacement for REST API. Is GraphQL service a replacement for REST API? And this kind of isn't it? Because you have only one one endpoint technically, which is the GraphQL, and then you form your queries, isn't it? So you don't really need the REST API.
So yeah, we don't need to have the REST API here. So just to make sure that I understood correct the question, we are talking about this kind of queries, this kind of services, or Angular services, or services between the communication. What kind of services?
Georgie, if you want to unmute.
Can you hear me?
Yeah.
Yep.
Yeah, I've never really come across it. I've heard of GraphQL, but I've got no experience over it. This is the first time I've ever come across it. But, you know, I'm used to a traditional kind of, you know, API where, as you mentioned, you know, I can have like my controller and then my function, and then the data that returns is pretty static, you know, depending on what, you know, I've wired it up to return, right? But what you're saying with this GraphQL stuff is that, you know, whatever query you write, it can return, you know, what you've requested from the client, right? Yeah, I'm just a little confused on, because I don't think I've seen the back end for the GraphQL. I don't know if I'm making much sense, but probably because I don't understand it well enough. But I can see you've got the Angular service, but that must be querying, as you said, you had like localhost, your port number, and then /GraphQL. That's like the back end, I'm assuming. Like, have I seen that in here or not? I'm not sure.
As you said, so this is it. And for example, here, let me show you. So this is the backend, the server is the backend. And here I have some resolvers, let's say. This is the project resolver. And what I'm doing here is with Mongoose models, I'm just getting everything sorted by order and just send it back.
Right. Okay.
So this is how I have it. And this is and this is the structure. So since it's a strict type, we have in the backend to form and to define all the types. For example, this is how the project looks like, and these are how the queries and the mutations are going to be. And then let me close all the others and have it like this. So we're like, I want to have the projects. So this is the project. I want to have the new project, and this is the new project, how it looks like. So as you said, so this is a replacement of, and the project resolver is like the controllers of the REST. This is the synonyms, let's say, in terms of REST and GraphQL.
Okay.
I hope I answered your question.
I think so, yeah. Maybe just a little more research is required from my side of things. But what's the database then that you're using?
The database is Mongo.
Mongo.
Yeah.
Okay. Lovely, thanks.
Actually, you can play around with this one. I will talk with Alex so that we can share all the links. The project is, of course, open source. We can do whatever you like and play around. Yeah, feel free. Yeah.
So we'll add it to the YouTube in the descriptions, probably once it's there on the GitHub and on the meetup as well, on the meetup page, if you want to look back. Okay, I think we got another question. How does it compare to OData?
How does
it compare to OData? I'm not sure what is OData.
Me neither.
Kash, if you can explain that a bit. Maybe we know, but by a different name, so I'm not sure.
I think I know. So do we mean by old data, meaning that if I have, for example, here one task, and if I update this one, how the cast is going to manage and how to combine all of these together? Is this the question?
So he's saying OData allows to send query params over RESTful APIs. So I guess it's kind of filters, if I understand. So you have an endpoint and then you can kind of pass filters maybe or something like that.
Yeah. Good one. So yes, you can have filters even on the queries. So if I want, for example, to create to query with a specific project, I have to define here the ID to be like, I want to query just this one, executed in order to have it. So the ID is a variable name that I decided to create, but I could also have like other parameters, like filters, for example. I want to sort by something else or something ascending or descending. So here I can provide my variables as I like to have them. And also has query variables, but to be honest with you, I haven't tried them, the query variables of GraphQL. So whenever I had to provide some filters, I provide them via methods, so like input variables.
Does it answer your question, Kosh? Cool. Okay. Nice. Was there another question?
And actually, all of these questions make me also recall because I haven't worked with GraphQL the last year, and I just presented, refresh all the memory, and all of these questions make me refresh even more. Thanks for this question, guys.
Yeah, Max is saying in the chat if you look at the backend side, to look at Nest.js. Yeah, Nest.js is really cool. I played with it, and it's so much easier to work with. Because you've got the TypeScript and it's got a lot of built-in things as well. So yeah, good shout out, Max.
I regretted it not to have it in Nest.js, really. When I created this and I saw what how many decorators we can have, I was like, damn it, I had to use it. But anyways, yeah, it has many cool things.
Cool. Any more questions? If not, Fanis, if you stop the recording.
So I will be like, stop
recording. And then I will request for the host.
Yes, you will receive an email notification when the cloud recording is ready.